This paper aims to document a scientific linkage between the underground testing of nuclear weapons and global warming. An empirical analysis of CO2 and fossil fuel data post-1945 suggests that global warming is not clearly attributable to greenhouse gas emissions alone. Our data indicates beyond statistical doubt a direct linkage between the rise in CO2 levels and underground bomb testing, rendering adverse consequences like global warming, radioactive contamination of terrestrial and marine ecosystems, and major disruptions to temperature patterns around the world. The derivative carbon footprint of underground nuclear testing is colossal and can bring about devastating human-induced climate changes which are not just massive but potentially irreversible. A British study published in the Physical Review Letters journal documented that nuclear bomb testing during the 1960s may have played a significant role in altering climate patterns around the world. The study concluded that nuclear bomb testing during the Cold War caused large-scale radioactive fallouts up to several thousand miles from the testing sites. This fallout altered the rainfall distribution patterns and increased the cloud thickness, thereby leading to global warming and irregular temperature distributions. El Said, 2020, Daily News Egypt, 2021. While the consequences of radioactive fallouts have been documented by researchers from time to time, one significant byproduct of the energy emission of nuclear tests has largely been overlooked by the environmental academia. The energy byproduct in question is CO2, carbon dioxide. A significant amount of carbon dioxide can be disgorged from the energy released by explosions of nuclear testing. If all the energy released by a 1-kiloton nuclear bomb, an explosive force equal to that of 1,000 tons of TNT, trinitrotoluene, were to be absorbed by water, the CO2 released would be the equivalent of 1,250 people for 75 years, using the lifetime footprint of 20 tons. In 1971, a 5-megaton explosion was detonated more than a mile below remote windswept Amchitka Island in Alaska, Weintz, 2017. It was the most powerful underground bomb test conducted by the U.S. to date, or perhaps by any nation on the face of the planet. This notorious explosion was 250 times more powerful than the bomb dropped on Hiroshima. If measured on the Richter scale, the explosion would return a result of 7.0, equivalent to the earthquake that destroyed Haiti in 2010. Increasing concern about radioactive contamination of groundwater from underground nuclear tests has reinforced the need for a basic understanding of how the radionuclide inventories of such tests enter and migrate through groundwater. As a basis for studying these processes, the physically and thermally disturbed geologic environment produced by such tests and its relation to the post-test distribution of radionuclides is discussed from a conceptual perspective. These concepts are used to support the development of a reactive transport model to evaluate the nature and extent of radionuclide contamination within alluvium surrounding a specific underground nuclear test at the Nevada Test Site, NTS.